Welcome to Khetz, and in this video I'll be continuing. So we have been talking about analytical geometry and circles in particular. I just want to talk about the intersection of circles. So let me draw two circles. I just want to open, and the circles can be any size, but for now I'm just going to draw one circle with a smaller size compared to the other, but they can be just about any size, or I can just draw them with the same size. It doesn't really matter. So the question is, do the circles cross each other or do they touch? Now, if they touch at a single point, then we can say that is a single intersection or a single point of intersection. And if they cross each other twice, then we can say they cross each other twice. But it can happen, like in this case, as you can see, the two circles are not touching at all, which means there is no intersection between the two. So there are quite a few cases that are of interest, but let's focus on just these three. So let's start with the first case. We are talking about, just so we don't forget, we are talking about intersection of circles. So intersection of circles. Now let's see. Let's now start with the first type of intersection, or let's call it case 1. And in this case, we are talking about circles which intersect at 2 points. Now, you might not have the diagram, because if you can see the diagram, it's quite easy to see what is actually going on. You can tell that they basically intersect there and there. So the first case deals with circles which intersect at 2 points, right? It's quite easy to see, once again, that from the diagram, they intersect at 2 points. But what if you are only given information about these circles and you had to determine whether they actually intersect twice, not at all, or once? So here's how you'd basically do it, or here's the reasoning behind all of that. So let's just assume that the dots which I drew are the centers of each of the circles, and the green line would be the radius of the one circle. So let me try to make it straight, or let me try to make it in line with the center of the other one. And now let's say the red one would be the radius of the other circle, right? Now here's a mathematical approach to determining whether we have two intersections, no intersection, or just one intersection point. So the reasoning behind this is, let's say we have, so basically we have R1, which is the radius or the length of the radius of this circle, and the red one would be the radius of the other one, right? Now, if we were to find the distance from this center to the center of the other circle, then we can actually use that. Let's call this D. The distance between one center of a circle to the other, let's call it D. And now this is important. This is an important quantity, because in this case, when we have 2 points of intersection, we expect this D to be less than the sum of the individual radii, right? Which is the plural for radius. Because if you look at the radii of these two circles, they actually overlap, which means they are not fully stretched. So if you were to fully stretch each of these, or if you were to pull these circles apart, then each of their radii would basically be longer than the D, this D that we have over here, right? So the D value that we have over there is less than the sum of the two, and that is when you have 2 points of intersection. And I guess this will make more sense when we look at the other cases. So let's just keep this for now and write it maybe up here and keep track of what we are talking about. So 2 points of intersection, we have D less than each of the radii combined. So now let's look at the second case, and maybe it will make more sense in this way. So now the second case, let's say we have, let's see. In the second case, we are now talking about a case where we have only 1 point of intersection, or the circles are basically just touching. So 1 point or just a touch of each of these circles, and expect that they only touch maybe on the circumference somewhere there, and we can see somewhere there. Let me just make these touch so that they actually do touch. So they actually do touch, and it makes sense using the analysis that we previously used that we expect to have the radii of each of these to equal the distance between their centers. And here's how that makes sense. Because they only touch once somewhere at the circumference, you can see that the distance between their centers, D, is basically equal to the sum of each of the radii. So if you add that and you add that one, then you expect to get that D value. Because you're basically just putting two circles next to each other, just so they touch at some point over there. So this distance in the centers would just be the sum from there to there and from there to there, right? In the previous case, you saw that we basically had these overlapping, which means the overall distance between the centers was actually less than the sum of R1 and R2. So that is the reasoning behind that, and I hope this now makes sense from this new discovery or what we've just talked about now. So you can put case 2 over there, intersection at what point, or when we only have this stuff touching at the circumference, then we basically expect the distance between, so don't forget that this is the distance between centers, right? Now let's look at the final case when these circles do not touch. So let's shift that, and I can't really get this to move properly. Let me just remove this, delete that, and this as well. And I just want to move this stuff just so it makes sense. So once again, it's easy to see from the diagram that the circles are not touching, but if you are only given some information, you have to do the calculations, and these are the calculations that I'm talking about, this stuff basically on the right hand side. This is how you prove, or this is how you check the case that you are looking at. Now, if they don't touch, then it just makes sense for the distance between the centers to be much greater than the sum of these. Because if you simply add these, you also have this space in between, which is not accounted for. So the distance D between the centers is basically now greater than the sum of the individual radii, right? Because there's this section over there, which it has to cover as well. And that distance over there actually has a name, or there is a definition of the shortest distance, which is between circles. So not necessarily with respect to the centers, but just the circles themselves. So when we talk about the clearance between circles, let me write it properly. Clearance between circles. Okay, my battery is now low. Let me just plug it in. Clearance between circles, we are talking about, this is a C. Come on. We're talking about the shortest distance. The shortest distance between the circles. Okay, so that is what we refer to as the clearance. It is the shortest distance between the two circles. And I've now effectively talked about the three cases that you can expect and how you actually check whether you basically have a case of 2 points of intersection, 1 point of intersection, or no intersection at all. So I hope this was useful, and you'd basically just do these calculations, or when you're asked to prove that you have a certain case, or when you're asked to determine what type of case that you have, but in either way or in either direction that you actually look at the problem, these are the basic things that you'd have to apply, or these are the basic things that you'd have to look for. I hope this was useful. I hope it was of value. If you have any questions at all, just leave a comment. And do email me if you have any queries, any comments, just about anything. And if you want to book a session as well, I have my email in the description. If you like the video, just give it a thumbs up. If you haven't subscribed, please subscribe, and I will see you in the next video.